Hello, we are officially starting U for AP Stats. So it's taken a while for us to get here, but we're here. We covered one unit in term one, which is typically pretty normal for me because we're figuring out what stats is all about. You're figuring out what quizzes look like, what the homework looks like. I am teaching you my procedures and my expectations, so everything takes a little bit longer term one. And then after term one, things get a lot faster. So typically at this point, most other AP stats classes have covered two chapters, if not three. A lot of AP stats classes at this point are starting the third unit or in the middle of the third unit, and we are just finishing unit one. I'm telling you that so that you have some reference point for how our pacing is going right now and how much we need to speed up. So we should have done the unit that you just tested on in half the time. After this unit that you just tested on, so starting unit 2, the units become shorter and you test more frequently. So we're still doing quizzes that go along with each lesson, but the units, like I said, don't last as long, and you will probably have 3 tests on quarter 2's grade, whereas quarter 1 you only had 1 test. So things start to pick up the pace from here on out. Hopefully you're ready for that. If you kept up with the can-you-dos, if you've kept up with the notes, then you're going to be just fine. But if you have been behind a lot of this quarter, it is going to become much more intense. So I would highly, strongly, as aggressively as I can with love, encourage you to stay on pace. If you get behind in this class, it just becomes so much harder to be successful. So I know it's a lot of work, but you signed up for it. So you gotta honor your word, you gotta have integrity, and you gotta fulfill the obligation, even though it's not that fun. So that all being said, we are going to continue on with an idea that we have spent quite a bit of time discussing already, and this is the idea of spread or variability within a data set. So I intentionally left out standard deviation from this unit because I think the idea of standard deviation matches a lot better what we're about to get into, which is z-scores and the normal curve. The normal curve is one of the most important things you will learn all year, just like describing a distribution is one of the big things in AP stats. The normal curve is another big thing, equally as big. So I have decided to put standard deviation in unit 2, but it is a continuation of the things that you talked about and just tested on for unit 1. So with no further ado, we will familiarize ourselves with standard deviation. So you can see on the heading of our note sheet that standard deviation has to do with measuring variability. So what we have talked about so far to measure variability is range and IQR. And if you have a really nice symmetric data set like this histogram or this histogram, you typically use range to describe the data set. So this one doesn't have any info on it, so I'll go back up to this one, and we would say the height varies from 59 to 78. We would use the range on this. So we would use our minimum value and our maximum value. I'm intentionally leaving this guy over here out. So nice symmetric distribution, we use range. Skewed distribution, we don't want to use range anymore. We don't want to describe the spread of our data set with range when most of the data is here and only a little bit of the data is out to the right. Or on this other one, most of the data is here and only a little bit of the data is to the left. So when you have a skewed distribution, you do not want to use range to describe that distribution because range is no longer accurate. Most of your data is to the left of the graph, and only some of your data is to the right. And same with this one that I just said. So instead of using range on distributions like this, we want to use IQR because IQR is going to give you the middle 50% of your data. And when you have a distribution like this, the middle 50% is like here. That is a much better description of the spread of this data than using range. Notice that the middle 50% does contain it does include the body of the distribution, but doesn't factor in the tails of the distribution. And it may be even more restricted than that. Like it may even be closer in like this. The IQR may even be more narrow, so not as wide as what I had marked, but a little less. And still, that's a better description of the data because you have a good amount of data points in the middle 50%, but once you go to the outer ends, that spreads out quite a bit. And like I said, range is not accurate anymore. So if I just flip really quick to a couple more graphs, if I wanted to describe the distribution of high school A, I think that I would say that this is roughly symmetric, and I would use the range to describe this distribution. Or I would say most of the data is between 1 and 16. But on this data set, I would want to use IQR because you have quite a bit more data out to the right. So I guess at the end of the day, the heart of the matter, what I'm really trying to get you guys to memorize and understand is that if you have a symmetrical data set, and I shouldn't say symmetrical, don't use that word. Symmetrical is not a word in stats. If you have a symmetric distribution, you want to use the range to describe that distribution. But if you have any skew at all, you want to use IQR. Now, we are going to move on to talking about spread in terms of standard deviation. So we know for center, we have two options. We have the mean and we have the median. And hopefully we know that if we are going to use the median to describe a distribution, then we're probably also using IQR, because you use the median when you have a skewed distribution. So IQR and median go together. IQR and median go together. Well, that means that mean and standard deviation go together. So that's why a lot of the time when we were doing describe the distribution problems, I would use range and IQR, because it's always okay to talk about range as long as you also talk about IQR. Range doesn't necessarily match one of the descriptions of center. Median and IQR usually go together, but median and range can also go together, and so that's why I would typically use both. I would give the median, the range, and the IQR. Now, mean, on the other hand, when you find the mean of any distribution, when you use the mean, I shouldn't say find, when you use the mean to describe the center of your distribution, you want to use standard deviation to describe the spread. I've said it a million times, I know, but I'm going to repeat myself one more time. When you use the median to describe a distribution, you always want to use IQR, and range is always good to add in, but IQR is like a must. When you use the mean of a distribution as center, you're good to use range, but what is better is standard deviation. So if you're going to use the mean to describe center, you're going to want to use standard deviation to describe spread. Whew. That was a lot of repeating. So here is our intro to standard deviation. Standard deviation describes the variation of data values around the mean. Around the mean. It measures the typical distance of the values from the mean. It measures the typical distance of the values from the mean. So when we find the mean, it's our average value. We take into consideration all of the observations in a data set, we add them together, divide by the number of observations, and this gives us an average value. So if the average on your Unit 1 test is an 85, that means that a lot of kids scored 85, some scored less, some scored higher, but most of us, the most accurate description of how well we did on the test overall is an 85. So the standard deviation is telling us, or would tell us, from 85, about how far away are the rest of the scores. So we know 85 is our average, and we know that not everybody scored 85, so about how far away from 85 did most of the kids score? That's the idea of standard deviation. It describes the typical distance from the mean. Okay, make myself little again. So, S sub x, this is how we denote standard deviation, is the standard deviation of a sample. This is the one that we are going to use the most often. This is the one that we use the most often. So I might just put a little dot on either side. Sigma, this symbol right here, he's named sigma. Sigma refers to the deviation of a population. And this is an idea that we'll talk more about in Unit 4 or 5. So S sub x is what we're typically or most often going to use because we're going to have a sample, meaning we're going to have a list of numbers that comes from the population. So as x, as S sub x gets bigger, the data is more spread out from the mean. And as S sub x gets smaller, the data is less spread out from the mean. And then we have a graphic with people standing around the flagpole. And each graphic is supposed to match the statement above it. So I want you to think about the mean as the flagpole. The mean of any distribution will be the flagpole. It's the center of the distribution. And the people are the observations in the distribution. The people are the observations. If you have a large standard deviation, what that means is these people are spread out further from the flagpole. Whereas if you have a smaller standard deviation, that means the people are closer to the flagpole. So this is a smaller standard deviation. This is your observations are close or clustered around the mean. This one, your observations are spread out from the mean. So in this graphic, observations are spread out from mean. This one is depicting observations are clustered around the mean. We are hoping for data sets, we are hoping for distributions that have smaller standard deviations. We want our data to be clustered around the mean, because that means that our mean describes the data better. If our observations are spread out from the mean, very far spread out from the mean, then our average value is less, I don't want to say accurate, but it's not as good of a description of our data set. So a bigger standard deviation means your observations are spread out from the mean. A smaller standard deviation is that the observations are closer to the mean. So this is different from IQR in that IQR only takes into account the middle 50% of the data, whereas standard deviation takes into consideration every data point, just like the mean takes into consideration every data point. So in order to gain a better understanding of standard deviation, we're going to talk about and practice calculating standard deviation. Now, family, this is not a very practical exercise in that I'm not sure you would ever be asked to do this from scratch like we're about to do on an exam. I do think that it is important for you to calculate standard deviation so that you have a better understanding of what it is and how it works. But the likelihood you're going to be asked to do this on a test, very small, very, very small. So we have a manageable data set. Our data set has 11 observations, and it is 11 high school students that were asked, how many close friends do you have? The responses are shown on our paper. They want us to make a dot plot to display our data and then find the standard deviation and then interpret the standard deviation. So I'm going to make my dot plot on top of this table. I'm going to start by labeling my axes, and my axes or my x-axis is going to be labeled number of close friends. And then I'm going to leave a little bit of space and I'm going to draw my x-axis. I'm going to start at 0 friends, and I'm going to try to get to at least 7 friends. You can start at 1 and 6, that's no biggie. Okay, I decided to go to 8. You could have stopped at 6, you could have stopped at 7. I'm feeling very bothered that my label is not centered, but whatever. We're just going to keep going because not everything can be perfect. Okay, I'm going to put my dots down. One high schooler had 1 close friend. Then we have 2, 2, 2. Then 3, 3, 3, 3. 4, 4, 6. Okay, that's a pretty nice looking dot plot. We can see that our peak or our mode is at 3. Most of the students have 2 to 3 close friends. So now that we have our dot plot, let's talk about how we would calculate the standard deviation. So the first thing that we need to do is find the mean of the distribution, because standard deviation is the average distance from the mean. The average distance from the mean. I'm actually going to write that down. Average distance from mean. And that is referring to the observations. The average distance from the mean. So who or what's average distance? The other observations. So we add all of these up. We add 1 plus 2 plus 2 plus 2, 3, 3, 3, 4, 4, 4, 6. You find it. We add them up, and then what do we divide by? Good. We divide by 11 observations. So we add up all the responses from our 11 high schoolers, divide by 3. You better be doing it. Oh, you didn't get your calculator out? Well, you better pause the video and go get your calculator. We got a lot of math to do on this page. I'll wait. I mean, where is it? Did you bury it under your bed? Did you leave it in your locker? Just kidding. Nobody has a locker this year. Okay, you probably found it. Hopefully you did. Your average value is 3. If you add up these number of friends, it adds to 33. You divide by the number of observations, that's 11. The next step is we want to calculate the deviation from the mean. And then it gives us this formula. Deviation is x sub I minus x bar. And you are probably sitting there going, say what? So I will explain to you what that is. So what it wants us to do is it wants us to take every observation and calculate how far away it is from the mean. So I is just the observation number. So we ended up having 12, just kidding, 11 observations. So my I values are 1 to 11. Well, then what is x sub I? X sub I would be, or x sub 1 would be the first observation. So up here, x sub 1 is 1. X sub 2 is 2. X sub 3 is 2. X sub 4 is 2, and so on. You can keep labeling these. All the way up to x sub 11. The reason that you have an x there is just to hold the place of whatever the first observation is. So this is the generic way of saying, or the universal way of saying, the first observation, the second observation, the third observation. So what is the first observation? 1. X is representing 1. Okay, so over here, let's write down what these are. So x sub 1 was 1. X sub 2 was 2. 2. 2. 3. 3. X sub 7 is 3. X sub 8 is 3. The 9th observation is 4. The 10th observation is 4, and the 11th observation is 6 close friends. So we calculate the mean. We are now working on calculating the deviation from the mean. So now we're in this column. This column is the deviation. So we have 1 minus the mean of 3. That's going to give us -2. And what this is telling us is this is 2 away from the mean, 2 in the left-hand direction. So the mean is right here at 3. 1 is 2 to the left. That's the deviation. Next one, we do 2 minus 3. That's going to give us -1. So that's saying that 2 close friends is 1 observation to the left of the mean, or a distance of 1 friend from the mean. So I shouldn't say 1 observation. I should say 2 close friends is 1 friend less than the mean. 1 close friend is 2 friends less than the mean. So observation 3 has a deviation of -1. Observation 4 has a deviation of -1 because those are all 2 close friends. 3 close friends, well, we do 3 minus 3. and that gives us 0 because 3 is the mean. So how far away from the mean is 3 close friends? 0 away, because 3 is the mean. So observation 6 has a deviation of 0, 7 has a deviation of 0, 8 has a deviation of 0. Observation 9, we have 4 minus 3. That's going to give us a positive 1, which means that 4 is 1 friend above the mean. Same thing for observation 10. And then observation 11 is 6 minus 3, or 3 friends above the mean, or 3 more friends than the mean. So 1 friend, 2 friends below the mean, 1 friend below the mean. The mean, 1 friend above, 3 friends above. So one thing, and I should have written these all in, just so that you have a visual of the fact for all of these deviations, you are subtracting the mean every single time. So the mean was 3, you're subtracting that because you are finding the distance from the mean. Okay, well, we're trying to find the average distance of the mean. So typically what we would do at this point, if we're trying to find the average distance from the mean, we would add up all the distances and divide by 11. If we want to know the average distance away, that means we want to add up how far away each observation is and divide by 11. Hopefully that makes sense. Because to find the average, you add all the friends, divide by 11. If we want to find the average distance from the mean, we add up all of the distances, divide by 11. So we go to look at all of our deviations or our distances. We want to look at our deviations or our distances, and hopefully some of you guys are recognizing, well, how's that going to work? Because when I take this one and I add it with this one, that's just going to cancel it out. And this one's going to cancel that one out. And this one is going to cancel one of these out. So if we add up these deviations, so let's add up the deviations. We have a -2. How many zeros did we have? 4? What? I add up all of my distances or my deviations and I get 0. Sad day. Sad day. So we can't add up all of the distances because the negative distances are going to cancel out the positive distances because the mean is right in the middle. So if you're looking at the center of a data set and then you're going to find the distance that every other point is from there, when you find those distances and add them up, they cancel out because the mean is the middle of the data set. So you have half of them that are to the left or negative and half of them that are to the right and positive, and those have a big old party, cancel out. So in order to get around that, for reasons that are much more mathematically advanced than even I can figure out right now, we square these distances, and we square them so that they're all positive. So that's your next bullet point. Square each of the deviations or each of the distances. I'm going to write distances above that just so that I have it for myself. Okay. Well, Famil, please bless that you use parentheses. If you don't use parentheses, your number stays negative and it defeats the whole purpose. Let me show you. -2 squared. Bam. -4. What good's that going to do us? No good. So parenthesis -2, oops, forgot the 2, squared. Bam, positive. Everything's as we would like. So don't forget thy parentheses. So I go through and I square all these. Really, you won't make us go through and square all these? Well, you know, I'm just going to do it because it's not like that much time. So there, I wrote it all out. Now it's going to go a lot faster. -2 squared is 4. 1, 1, 1, 4 zeros, 1, 1, 9. Okay, family, now notice, after we square our deviations, all the things are positive. All of the things, all of the squared deviations are positive, and we need that so they don't all just cancel each other out. Okay, so now we proceed, as we should have, to find an average. We're going to add all of those squared deviations. We're going to add all of those squared deviations. I'm just finding my cheat sheet really quick, family. I'm still here. So, what this looks like, there's some fancy schmancy symbols for this guy. It's sigma. Well, really, it's capital sigma. This is capital sigma. This is baby sigma. Fun fact, since this lesson already isn't taken 10 million hours, my 2 pugs, I probably already told you this, I got Delta first, and I named her Delta because I had this dream of having 2 little puglets, and one of them would be named Delta, and one of them would be named Sigma. So most of you guys know Delta is one of the math symbols, and now we're talking about Sigma, the math symbol. So I get Deli first, I get Delibug first, and then I go to get my second dog, and once it's go time, man said, no, no, no. You cannot name our new pug Sigma because it sounds too much like cigarette. He didn't want to call our little baby pug Siggy. Sad day. So now I have Delta and Murphy. I love Murphy though, and I love Murphy's name. So back to business. Sorry. Capital Sigma is this guy. Baby Sigma, this guy. So, to write that you're adding all of the squared deviations, that's what this sigma means. This sigma symbol, means add. What are we adding? We are adding all of the squared deviations. So that's what these symbols mean. Add all of the squared deviations. This has a fancy name. This is called variance. This is called variance. So I'm going to go over to my table here. Underneath this table, I'm going to write the variance equals. Then I'm going to add up all of these squared deviations. Beep, boop, boop, beep, boop, 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 beep, boop. That's the sound in my brain adding them up. We end up with 18. So our variance is 18, or the sum of our squared deviations is 18. Now, just like with any average, we got to divide. But, plot twist, we divide by n minus 1. So we're not going to divide by the number of observations. We're going to divide by the number of observations minus 1. Why? For reasons that are too mathematically advanced for where we're at right now. So we add up all of the squared deviations and divide by n minus 1. Well, we had 11 observations. We minus 1. Beep boop. That's 10. So we would do 18 divided by 10 and get 1.8. But wait. I need to look at you. We have a little bit of an issue here because we didn't take the distances and divide by the number of observations. We took the squared distances. So we got to now square root what we just found. I know, so weird. So weird, but we got to do it. So since we squared all of the distances, now that we have the average squared distance, we need to root it to find the average distance. Let me say that again, because you know I love to repeat myself. We have found the average squared distance. We have found the average number of squared friends from the mean. Ain't no thing as squared friends, so we got to square root all up in here. So we're going to go from friends squared back to friends. Okay, let's do that. So that's our next blank. Square root the quotient. So we take our 1.8 friends squared and we root it. Beep, boop, boop, beep, boop, beep, boop, boop. And that gives us 1.34. That is 1.34 friends. I don't know that 1.34 friends is any more real than a squared friend, but that's fine. That's another thing all on its own. So now I know the average distance from the mean is 1.34. So the big old mathematical formula for standard deviation is right here. You got the ginormous root, you got the sum of the deviations squared, and the dividing by n minus 1. So if we wanted to not do 50 million steps like this, we could have just plugged in 18 divided by 11 minus 1. I mean, we would have still needed to go through and square all the deviations and add all that up, but we wouldn't have to break it out into all these mini steps. If we plug this into our calculator, so the root symbol on our calculator is blue button, x squared button. See how on top of it you have a little blue root? So you hit your blue button to get the blue function. And then, family, if you want a fraction, you hit the green button and the y equals. Then you choose that first one. That's numerator over denominator. Bam. 18, arrow down, 11 minus 1. Everything's all good in the hood, 1.34. So if you want a fraction all up in your calculator, you got to hit the green button and the y equals button. And we are almost done. We are getting there. Get your confetti popper out because this party's almost over. Now that we know our standard deviation, we have to interpret the standard deviation. The directions on here said interpret the value. So the number of friends, and then we're going to commit this to memory. I'm just looking for a pen color that I would like, and I'm not seeing one. Sad day. I'll use purple again. The number of friends typically varies the number of friends typically varies by about 1.34 friends from the mean of 3 friends. So most people have between 1.66 friends and 4.34 friends. Most people will be 1 standard deviation below and 1 standard deviation above. That's what that means. Whew. Maybe I should say that one more time, because I am a repeating queen. What this means is that most people will be this distance away, below and above. So 1.34 below and 1.34 above. Okay, I'm going to write that down. Most people, and by people, I mean most of the 11 students. Most students between 1.66 and 4.34 friends. That is 3 plus and minus the standard deviation. Now I'm going to check to make sure that that's right, because secretly I'm not 100% sure that that's right. So between 1 and 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 11. That's most people. Booyah. Okay, really, truly, we're almost done. On this next page, all we need to do is highlight because, well, on the top part, all we need to do is highlight because this is really important information. Please highlight it. Please try to understand it and commit it to memory. Hopefully, oh man, I meant to tell you this 45 minutes ago. Listen, I'm a little bit worried that some of you guys are just watching the subtitles and filling out the notes and not truly listening to the lesson. Like, I'm worried that maybe you're just going through, pausing, writing the stuff down, and moving on. Disaster time. You gotta watch the videos. I think you should listen. You can put the subtitles on, but I don't think that you get as much out of it. Please bless that you have been with me for the last 47 minutes actually watching this. If you are, you're probably like, lady, if you don't speed it up, I'm gonna drop this class. I'm gonna rage quit. Don't rage quit. We're almost done. I'll stay on task. Okay, the first important thing. So this up here at the top says, more important than the details of calculating S. So more important than this, because remember, before we even started it 30 minutes ago, I said, you ain't never gonna probably do this on a test, because wasn't that an adventure? So, on to this side, more important than the details are the following 3 things. Before I forget, the reason why you do not have to know how to calculate this on a test is because your calculator will give it to you. Remember when we would find one variable stats? So I'll just quickly go in and choose a list. I'm going to go list 2. You can't see the screen. Teacher, get a dang grip. I'm going to calculate my one variable stats. See how it gives you standard deviation right there? Yeah. In fact, I could quickly put in the friend data set. So I'm going to put it in list 3, and I really am going to go quick. 1, 2, 2, 2, 3, 3, 3, 3, 4, 4, 6. Stat, calc, 1, list 3, boom shakalaka, right there. Standard deviation is exactly what we got, 1.34. So the reason why we have this list of things that are more important than calculating it is because our awesome calculator will calculate it for us. So number 1, we are measuring spread about the mean, and we should use this only when mean is chosen as the measure of center. Should be used only when the mean is how you describe the center. Because remember, median and IQR go together, and range is okay to use, but you have to use IQR. Mean and standard deviation go together. So median and IQR, mean and standard deviation. Why? Hop down to the last bullet point. Because standard deviation is not resistant to outliers. So if you're using the median to describe your distribution, you're probably doing that because your distribution is skewed, which means that you should not be using standard deviation because it's not resistant. Remember, standard deviation looks at the distance from the mean to every single observation. So you only use standard deviation when the mean is chosen as the measure of center. Why? Because the mean is not resistant. In fact, the use of squared deviations makes standard deviation more sensitive to outliers. More sensitive to outliers. So then it gives you an example. They did travel times of 15 North Carolina workers and found that the standard deviation was about 15 minutes. If they took one value out of that data set, the highest value, it changed the standard deviation to 11.5 minutes. So because you're squaring the distances, it makes the outliers have an even bigger effect on the standard deviation. Like, it's because of the squaring it. It's almost like squaring the effect of the outlier. So use only when mean describes the center. Why? Not resistant to outliers. The second bullet point I personally think is an easier one. It is that standard deviation has to always be greater than 0 because you're measuring a distance. Distance can't be negative. Position can be negative. A position being negative tells you it's below or to the left, but a distance cannot be negative. It can be 0 only when your standard deviation is the value of the mean, which you would never get because that would mean your entire data set is one value. It would mean that your mean is 5 and then every other value in the data set is 5, and that's how you get a standard deviation of 0 because none of them are other than the mean, which is 5. And then we already went over this. As observations are more spread out, standard deviation gets bigger. Okay, S sub x has units. This guy is important and something we're going to really want to try to remember. S sub x, or the standard deviation, has units of measure, just like the original observations. So here, the unit of measure was friends. So our standard deviation is 1.34 friends. You have to use the same units. Okay, I think that is the whole shebang. So the last thing that we have to do is interpreting standard deviation, and we've already done that on the previous slide. The sentence frames are typically the same. The first thing that you write down is the context. The first thing that you write down is the context of the problem. So the distribution of fat content in 12 hamburgers has a mean of 2283 and a standard deviation of 9.06. Interpret standard deviation. The first thing you say is context. So what are we looking at? The fat content of hamburgers. So the fat content of hamburgers, or the hamburgers, then this phrase is always next. Typically varies. Just commit it to family. Just kidding. Just commit it to memory. Family. That's where I was going with that. Typically varies by about. That always stays the same. Typically varies by about. Stays the same every single time. So I'm going to be highlighting that up in here. This never changes. And then you give the standard deviation with units. So the fat content of the hamburgers typically varies by about 9.06 grams from the mean of 2283 grams. So context typically varies by about, oh, this is the same too. Standard deviation from the mean of mean. Okay, so now you're practicing it on the bottom two, and I covered mine up because I already did it. So you are interpreting the standard deviation for the life expectancy of frogs and the standard deviation for the number of miles a Nissan Pathfinder lasts. So you use this like almost word for word to interpret. Pause the video and try it on your own. I beg you. I beg you. I beg you. Really try it. Okay? Okay, pause. Okay, hopefully you really pause because I'm about to show you my answers. So on the, oh, are you seeing this? I just ripped my paper so hard. And this, okay, sorry. The frogs is the life expectancy of frogs. So I'm taking the context right from the problem. The life expectancy of frogs typically varies by about 4 months with units from the mean of 18 months. So hopefully you can see the things that I highlighted that are the same. You can see where I got the context. Okay, next up is the Nissan Pathfinder. The mean number of miles a Nissan Pathfinder will last. That is your context. Typically varies by about 10,000 miles from the mean of 100,000 miles. So, a couple things before I finish up. What this means is that most Pathfinders will last 90,000 to 110,000 miles. That's not very many miles. So what this means is that most of them, a majority, more than 51%, in most cases it's really 70%. 70% of the Pathfinders will be between that mileage. How do I know? You're about to learn it. You're about to learn how I know that this is about 70% of Nissan Pathfinders. Then up here, what does this mean? Most frogs, which is really about 70% of frogs, will live between 14 and 22 months. Most frogs will live between 14 and 22 months. How am I getting that? -1 standard deviation, add 1 standard deviation. Are we good? Hopefully we're good. So I think I say this in every video, I was thinking that this was going to be a shorter video, but that finding the standard deviation from the table business is a doozy. So one last thing that I want to mention, because when I went through and checked your can you do's for the test, I was shooketh by how many of you guys are not doing your can you do's. Y'all need to be doing your can you do's. This is the intro. This lesson is the intro, the basics of standard deviation. The can you do's are the actual learning of standard deviation. You know the basics now. I'm not sure that you really learned anything. I mean, now you know some things that maybe you didn't know, but now you gotta learn how to use it. What does it mean? And the only way you learn that is by practicing. And I'm thinking that you guys will see that or have seen it reflected in your test score. I am willing to bet if you didn't do your can you do's, your test score reflected it. And if you did, your test score reflected it. So now you have to do even more learning. What is my suggestion on doing your can you do? I personally would get out my can you do and I would do problem 1, and then I would look up the solutions video and watch the solution to number 1 right after I do it. Number 2, do number 2. Oh, I don't even know how to start number 2. That's okay. Go to the solution video, listen to the first part, pause it, and then try to do it. Don't just let me do all of the problem. So I would not do my entire can you do and then watch the solutions video. I would get the solutions video out, do number 1, check number 1. Do number 2, check number 2. Don't know number 3, watch the video. That is going to give you the most benefit out of the resources that you have. I think I'm going to say that at the end of every single video for a long time. And hopefully it'll make it through to some of you. Okay, that's it. Love you, Mooey. You only know how to do half of your can you do at this point. So you can either do the first half of your can you do now, or you can wait to watch the Z-scores lesson and then do the rest of your can you do. These have been split out into 2 lessons. So standard deviation is 1 and then Z-score is the other. They are both on Can You Do 7. Okay, that's it. Any questions? Email me, come in, whatever you got to do. I'm happy to answer your questions. I actually love it when you guys have questions. Okay, that's it. I'll stop babbling to you. Love you guys. Hope that you have a great day.